Okay, let's do it again. What is shown here in the board is a figure of a parabola. Parabola, first of all, we have to identify the components or the parts of the parabola. First, we have to know the vertex. This one here is the vertex. This point here, this is what we call the focus. And this line here, which is the back of the parabola, which is parallel to the x-axis, this is called the directrix. Now, what is the relation between this directrix and the parabola? According to the definition, any point here in the parabola, the distance from the focus to that particular point is equal to the distance from that point to the directrix. So meaning that this distance here is equal to the distance from here to here. By the way, one more thing. This segment here, which is traversing the focus, this is called the latus rectum. Okay, I think all the important parts of parabola is already mentioned. And I think you can identify where it is when we're talking about vertex, focus, directrix, latus rectum. So now we are going to find the relation between the y and the x, which is the equation of the parabola itself. So we'll go back to the definition. According to the definition, the distance from the focus going to any point here in the parabola is equal to the distance from that point normal to the directrix. So if we will pick the relation of that one, so let's see, this is the y, distance y, and from here to here, this is, let's see, this is x, as this point here is x, y coordinate. Now, let's assume from vertex to the focal point, the distance is p distance. So which means that this p distance is also from vertex going to the directrix. It's also p. So now, what do we have so that we can have a relation between y and x? So we'll take a look. this one. So if this is the x, this should be, this distance is y minus p, this distance here, y minus p. So meaning that this is the hypotenuse of this component and this component here. So let's see. We'll see this one is this distance here is equivalent to y minus p squared plus x squared square root of it, because it is the hypotenuse. So now if this distance here and this distance here, they are equal, so meaning that they are, we know that this distance here is y, right? So if this is y, so this is should be p, so this distance is y plus p, y plus p. So now we have all the relationship now. So we'll simplify these things. So I want to get rid of this square root, so I have to square that one. So y minus p squared plus x squared is equals to y plus p squared. So we have to expand this one, so it will become y squared minus 2py plus p squared plus x squared equals to y squared plus 2py plus p squared. So to simplify further, we have to cancel some commons in the both sides of the equation of the. So this p squared can be cancelled on this p squared here. So this y squared, also this y squared here, will be cancelled. So now what we have left in the equation? So this is minus 2py, we will transfer it to the other side, to transpose. So x squared is equals to, because this is negative, transpose, so it become positive. So 2py plus 2py, so x squared will become 4py. So we will take the y as a subject. So y will be equal to x squared over 4p. So that will be the equation of this parabola, which means that this P is 4P.